Hi, welcome back to physics. What is the actual color of sky? What is the actual color of sun? During daytime, you can see that sun appears as white. But during sunset and sunrise, what is its color? And what about the sky? So sky is actually a space, right? Empty space. But we see it as blue color. Will it be the same if we are observing from moon or from any other planet? Well, we can discuss this today. So welcome to the last topic of our chapter, that is scattering. Before finding the answers for the questions, let us discuss what is scattering of light. When a beam of light falls on small particles, this light will be scattered. And this scattering of light will not be the same for all the colors of light. As we discussed in the last class, white light contains 7 colors, namely Vibgyor, right? And we studied that violet is having minimum wavelength and red is having maximum wavelength. So my point is, the scattering of light depends on the wavelength of the light. It is like this. The scattering of light will be more if the wavelength of light is less. In other terms, we can say that when the wavelength of a light increases, the scattering decreases. See, this is in the case of very small particle. But for relatively a bigger particle, the scattering will be same for all the colors. Same for all the colors with different wavelengths. So, in short, if a white light, a beam of white light incident on a very tiny particle, which color will be scattered more? Yes, the light with minimum wavelength. Among the white light, which are the colors having minimum wavelength? Yeah, violet, indigo and blue. So among Vibgyor, when they fall on very tiny particle, blue, violet and indigo will be scattered more. And the scattering will be very less or minimum for red color because red is having maximum wavelength. Now let's go through an activity to explain scattering.
A source of light is placed at the focus of the convex lens to give parallel beam of light. A beaker with water, a cardboard with slit, a convex lens and a screen are arranged as shown. Add sodium thiosulfate and concentrated sulfuric acid into the beaker and stir well. Pass the beam of light and observe the solution and the screen. We find fine microscopic sulfur particles precipitating in about 2 to 3 minutes. As the sulfur particles begin to form, we can observe the blue light from the sides of the beaker. This is due to scattering of short wavelengths by minute colloidal sulfur particles. Observe the color of the transmitted light from the fourth side of the glass tank facing the circular hole. It is interesting to observe at first the orange-red color and then bright crimson-red color on the screen.
Now with the light of the observation from this activity, let us explain the blue color of sky and the red color of sun. We know that the atmosphere of Earth consists of many gases, that means air particles, and there will be dust particles and also water droplets. So when sunlight enters Earth's atmosphere, this beam of light will be scattered due to the particles present in the atmosphere. As I told you before, among Vibgyor, the minimum wavelength is for violet and maximum wavelength is for red light. So we can say that violet, indigo, blue, these colors are having minimum wavelength and red will be having maximum wavelength. So when they hit on these tiny air molecules or particles present in the air, which will be the color that scattered more? Yes, obviously the light having minimum wavelength. Or we can say that violet, indigo and blue will be scattered more. And these colors will be scattered and hence the atmosphere of earth or sky will be in blue color. Now you may be thinking like not only blue, right? Violet and indigo also have lesser wavelength than blue. Then why we are seeing it as blue? Answer for this question is, for our eyes, blue color is more sensitive than violet and indigo. And one more reason is there, among the solar light or solar spectrum, that means Vibgyor, than violet and indigo, blue color have more intensity. So this is the reason why the sky appears blue. Now let us see why the sun appeared to be red during sunset and sunrise. If we are in this position on the surface of earth and during sunrise, if sun is over there, and during daytime or noon, sun will be above us, right? And at these two situations, sun will be nearest to our position during noon time, and it will be at maximum distance from us during sunset and sunrise. So we can say that in short, the sunlight has to travel maximum distance to reach us during sunset and sunrise, and it will be covering minimum distance through the Earth's atmosphere during noon time, right? Now let us consider the sunset or sunrise. So I told you during sunset and sunrise the light has to travel through the Earth's atmosphere to reach us with maximum distance. So while traveling this much distance, all the lights with lower wavelength will be scattered from the atmosphere and will be lost, and only the light having maximum wavelength, that is red, will reach our eye. In short, we can say that during sunset and sunrise, only red color reaches our eyes. So we will see the sun as red. This is why during sunset and sunrise, sun appears as red. Now during daytime or at noon, you can see that the sun is in white color, right? But still scattering is there in the atmosphere. But the problem is all the violet, indigo, blue, green, yellow and orange color are not scattered and lost. Only a few of these colors are scattered, and remaining color will reach our eye and we will feel it as white itself. Now, you might have come across the situations like this shown here, right? In misty days or foggy days, you can see the path of light traveling through it. This is known as Tyndall effect. This is also due to the scattering of light. You might have studied in lower classes that when a beam of light is traveling through a colloidal solution, the path of that light is visible, right? This is Tyndall effect. Now, I hope all these phenomena related to color of light is clear for you. If you have any doubt, please ask in the comment box. Thank you so much.